Hello, welcome to the lecture for the workflow for Program 3, Planet Travel, or sometimes called Planets. As you can see, I've already created a new project. I've named it Nelson P3 Planets, and I've also created a new file for my driver. I've put on my header, name, email, and the file name. Okay, it's time for my pound includes for this project. And I'm going to include IOStream because there will be conversations with the user, input and output. And I'm also going to include, if I can spell it, IOmanip. Because I think I'm going to want to do some formatting of my output. I'm also going to pound include string because I will need to ask for the name of the person traveling. And I'm also kind of pound include vector because we're going to use vectors to store our data. Finally, I will include using namespace standard. There we go. Okay, and here we go. We're starting out with int main. I always like to throw return 0 in at the end so I don't have to worry about remembering it. So the first thing I'm going to do is I'm going to declare variables. And that includes creating the vector objects. Okay, so what am I going to need? I'm going to need a variable for weight and also for something I'm going to call new weight. I'm going to need some integers for the planet that I'm on, the speed that the user is going to be traveling, years, days, hours, and travel time. If I need more variables, I can always come back and do it. String name. And whoops, I need a comma here. And also string go again. That's going to be the answer from the user where I know whether I want to continue looping. Okay. So I have a couple of constants I'm going to add right now. Constant int hours to years. Well, how big is that? Let's take a look. I believe our spec says to assume that there are 365 days in a year and there are 24 hours in a day. So hours to years is 24 times 365, which is 8,760. Also, just because I'm going to be using it, I'm going to call that hours. Whoops. There we go. Okay. Then I'm also going to make a constant for hours to days. That one's pretty common. That's 24, but it's always good to have your constants there. Okay. So let's start creating our vectors. Vector of strings. The thing that we're making a collection of goes in these little brackets, and we're going to call it planet name, and we'll have a list of planet names. I'm going to create a vector of doubles for the relative gravity. That's the number that's in our spec that gives the percent of the gravity on the other planet as a function of the percent of the gravity on Earth. If you look at our spec, it gives us some useful information. It tells us how to calculate the weight on the new planet, the relative surface gravity times the weight on Earth. And it tells us how to calculate travel time, which is the travel distance divided by the speed of travel. Here are the 3 items of data we're going to be putting into our vectors: the strings, the doubles, and we'll talk about what goes into this vector for the distance from the sun. Okay, now on the surface it looks like the distance from the sun is an integer. But if we look really carefully, once we multiply 2,793 times a million, we are out of range of how big a number can be described as an integer. So we can't actually use integers for that. Now, we could do a number of things. We could use these numbers as integers and then remember later on to multiply them by 1,000,000. We could change them and into doubles, because doubles are certainly way big enough. We could use unsigned ints, because unsigned ints are can be twice as large as integers because they have twice the range. Or we can use long longs, which is a new integer type, and those are just enormous. But I think that I am going to use, I'm going to use these numbers, and remember that these represent millions of miles. So I will have to include that in my calculations. You may choose any one of the suggestions that I've given you. So these are going to be a vector of ints, but I'm going to remember that I have to millions of miles, okay? So I'm going to have to convert that later on. Now we need to fill the vectors, planet name, and the way we add to a vector is to use the function pushback. And what that means is that we add an element to the end of the vector, onto the back. And what's our first, here, let's see, there we go, that's good. Okay, our first planet is going to be Mercury. Be sure you add it as a string literal. Otherwise, you would have to create variables, string variables, and then assign that into the variable. And then you're going to add all the rest. You're going to push back all the rest. So it'll be Mercury, Venus, Earth, Mars, in that order, to fill up the planet name vector. The next one I'm going to fill is the double vector, which is the relative gravity. Why don't I just take what the IntelliSense gives me? Here we go. Relative gravity dot pushback. Okay, and the first number is 0.27, and that is the one corresponding to Mercury. We want to keep these all in the same order so that when we use the first element of the vector, Mercury, then the relative gravity will match and the distance from the sun will match. So distance from sun dot pushback, and that is 36 million miles. So I'm just going to put 36 in there. And you're going to have some more of those to push back yourself. Just read them off of the table and you'll be fine. Okay, next, after we filled our vectors, we had better see out the header. And we know what goes into the header: name, the program name, and a little description of your program. And I'm going to let you go ahead and do that. Now we're going to ask for user input. So first, let's ask for the name. Please enter your name. And I think I'm going to put another \n here because I'm going to want the cursor to go down to the next line so that people can enter their name. If you don't like to do that, I would suggest leaving a space here so that what the user will see is please enter your name, and then there will be a space and they can enter their names. Okay, now I am going to use a get line to read this name. Why am I going to use a get line? Because if I use a CN and someone puts in their full name, such as Yvonne Nelson, it will only read the first name and leave the second part in the stream. Then when you go to read your next input, it will still be there and you will crash. So in order to make sure you read the full name, you use a get line. It will read the entire line, all punctuation, and also read the new line character. So you will be set to read the next line. Okay, the next thing I'm going to ask for is the weight of the user. Well, didn't mean to do that. Please enter your weight. Again, I'm going to go to the next line. This time I can use CN because it's just going to be a number. And what's the number? What's the, here's my variable, it's weight. Okay, now after this I'm going to need to do a cn.ignore, because when we use cn, then it leaves the new line character at the end of the stream and it doesn't read it. So when you go back and use a get line, it will read that, think it's done, and it won't read what it wants you to. So when you are mixing CN and get line, be sure to put in a cn.ignore after every CN. Okay, so now we are going to open a loop. We call this a play loop. And what this is going to be is it's going to allow the user to calculate as many intergalactic voyages as they want to. Okay, so let's start out. Now we're going to ask for the velocity. And now that we have the person's name, we're going to use it and make this personal. I'm going to put a comma after that because this is going to be the person's name. Then I'm going to say comma, and I'm going to say how fast would you like to travel? And this is going to be in miles per hour. Okay. There we go. All right, once again, I'm going to put in a new line. And I'm going to see in speed, which I believe is our variable. And once again, C and dot ignore. Okay, now we have all of the basic information. Now we need to have the user choose their destination. Choose your destination. I'm going to say by selecting a number. I'm going to be very specific because I want the user to not have any doubt about how they're supposed to answer me. Okay, so now I have to present the user with a menu because there are 8 planets for them to choose from. And so what I'm going to do is I'm going to use a for loop, and the for loop is going to loop through my planet name vector, and it's going to see out each of the planet names. So let's see what that looks like. For int I equals 0, I'm going to start at 0 because why? Because almost everything in C++ is 0 indexed, so we don't ever start counting with 1. We start counting with 0. I is less than how many do I have? I have 8. That means their numbers are going to be 0, 1, 2, 3, 4, 5, 6, and 7. I never want I to become 8. If it's 8, then it's going to be out of bounds, and I'm going to have a problem. And I++ means that each time I run the loop, I will have increased the value of I by 1. So I'm going to start at 0, the next time it'll be 1, the next time it'll be 2, and so on. So I'm presenting my menu, which means I need a cout, and I'm going to look at my vector. Planet name dot at I, and that gives me the planet name at that location. I'm going to add another formatter called ENDL, endl, which means end line, so that the next time it comes through the loop, it will have gone to the next line. That way I'll get one planet name on each line. It's similar to \n, only it comes at the end of the line. Okay, now I said to select, a number. So I need to add a number. The user does not know about 0 indexed. So they're going to want to choose numbers between 1 and 8. So I can do that by also seeing out a number. I, which is going to be whatever I is, originally 0, plus 1. Okay, so now it'll see out a number, 1, 2, 3, 4 through 8, and then it'll see out the planet name. But I didn't put a space in there, and the planet name will be jammed right up against the number. Well, that's no fun. So I'm going to put in a couple of spaces there. And, you know, I'm also going to put in a dot. So it's going to be 1 period and then the planet name. Okay, I like to do a little formatting. So when this loop has run, then the user will have the opportunity to see a menu that will have all of the planet names listed with a number in front of them. And so now we're going to ask them to enter their choice. And again, I'm going to go to the next line because that's the way I like to do it. You don't have to, that's just me. And that's going to be planet. That's the integer that tells us which index in the vector is the planet that has been chosen by the user. I'm going to add a cin.ignore. And then I'm going to remember, but C++ is 0 indexed. So I'm going to do planet minus minus. What does that do? It subtracts 1 from the value of planet. And so they're never going to choose less than 1, so we don't have to worry about that. But now planet is 0 indexed. Okay, the next thing to do is to calculate the distance to the planet. And we're going to do that by calculating an intermediate value for distance. We did not create a value for distance because it's not really an important variable. But all we need to do is create an intermediate one right here. Int distance is equal to, okay, the distance to the planet that we've chosen, which is distance from sun at planet, and that is now correct because that is 0 indexed. Whoops, I'm not done. And I'm subtracting distance from sun dot at Earth, and I think we all know that Earth is the second, it's actually the third planet, so it's 0, 1, 2. So its index is 2. Now the other thing we have to do is we have to multiply the distance by 1,000,000, don't we? So and the other thing we need to do is make sure that we have the absolute value. So let's do the absolute value first. Whoops. Okay, so that way, if the planet is closer to the sun and the distance is negative, that's okay. And if it's farther than the sun and the distance is positive, that'll turn out well. And now we need to multiply. So distance equals distance times 1,000,000. Is that 1,000,000? Yeah. Okay, so now we've corrected the kind of convenient shortcut that we took in our vector. If you make the vector type a long or a double, you don't need to do this. Of course, then if it's a double, then you'll have to cast it back into an int later on. But that's okay, you know how to do that. So you have your choice about how to handle that. Now we can calculate travel time, and that equals to the distance divided by, yes, the speed. Okay, there we are. We've calculated travel time. And now we need to calculate travel time in years, days, and hours, because this travel time is in hours. So in order to do that, we're going to do integer division. It's very handy when you're trying to break down something like this. Years, which is an integer, is equal to travel time divided by hours to years. Okay, these are all integers, so any part of the decimal will be ignored, truncated. Now, when we calculated it by hand, we had to calculate how many years we took off of our travel time, which gave us a new number that we could then divide to get the number of days. But we can do that more easily with the computer using the modulus function. Days equals travel time mod hours to years. Now, what does this give us? It gives us the number of hours that were thrown away because we did integer division. It gives us the remainder. Okay? So, but this is still not days. This is the number of hours that remained after this calculation. So now we're going to divide that by hours to days to get the number of days. This is also integer division, so we will have more left over, more hours left over, and that will be hours equals travel time mod hours to years once again, we're at the same place where we divided travel time by hours to years and got the part that's left over. And then here we divided by hours to days. Now, we wanted to get to this place, but we don't want the hours to days. We want the hours left over, so we're going to mod it again. And that will give us the number of hours that are left over at the end. Not too bad. Okay, now we are going to set precision for our display. And what are we going to do? Cout dot set okay, cout dot. I'm going to set flags first, and what I'm going to do is I'm going to set iOS, which tells you which class it comes from, and fixed. Fixed means that it's not using exponential notation. And then I'm going to say I'm also using show point, which means I want to see the decimal point. Then I'm going to have cout.precision, and combined with this first statement, that'll give me 2 decimal places. Oh, I've had one more thing to calculate. I almost forgot, and that is calculate the new weight on the planet. So how are we going to do that? That one is simple. New weight is equal to weight times, okay, so what was the name of our vector? It was relative gravity. Dot at planet. Okay, so that is going to give us our new weight on the other planet. Now we can see out. Oh, let's see. Name. See out. Weight on Earth. Whoops. And that needs to be pounds because we need to have units always. Okay. And I'm just going to put etc. because I know that you guys know how to finish displaying all the information. We're going to meet name, weight on Earth, weight on the planet, the chosen destination, the travel time in years, days, and hours. Okay, finally, we need to ask the user if they want to calculate another one of these. So, see out. Would you like to travel to another planet? Oh gosh, there we go. And I'm going to tell the user, I'm going to make sure, and you guys need to do this too, make sure you tell them what the choice is. And I'm telling them that I'd like them to type either yes or no. Okay, it depends on what you like. It can be Y or N or 1 or 2 or whatever, but you have to tell the user what to type. Otherwise, they're just sitting there looking at you saying, well, what am I supposed to do? And then I'm going to use a get line because this is going to be a string, and this is my go again string. And so they're going to type in either yes or no. And now I have to end my do while loop. You see, I've begun it, but I have not ended it. Now I just added this one closing brace to end the loop. And the way I do that is I type while, go again is the same as, what do I want it to be? Yes. Oh, yes. So as long as the user says yes, then when they come here, they're going to go loop up to the top of the loop again, and they're going to be asked for their speed and the destination again. Okay? When they're done, when they say no, then they're going to drop out of the loop. And we are going to see out a goodbye message. Okay, well that's it. You've just finished program 3. There's some of it left for you to fill in, but most of the logic is there, and I know you have the skills to do the rest of it. If you have any questions, you can always email me or ask it on the discussion board, or come to online office hours, or come to the eLab. We have many resources for you, so we can get you help if there's any questions. Not a problem. Okay, bye.